Hi everyone, so my name is Audrey. I am the Assistant Director for CNRS in Washington, DC. So yeah, today I'm going to introduce you the speaker for this session. So yeah, let's welcome, okay, so great. Let's welcome Etienne Menard. So thanks for being here, Etienne, and we are pleased to listen to you. So Etienne, you were the founder and CTO of Helios Lite. So you possess an engineering diploma in electronics from the National Polytechnic Institute of Engineering, and you are currently developing a new class of floating structures for utility scale power plants, and you are a proven technology developer with almost 40 over 40 patent applications granted, which have applications in the industry across multiple fields. So you are going to present your work to us. So please feel free to do it.
Yeah, thanks a lot, Audrey, for the kind introduction and for the opportunity to present Helios Lite. This workshop is very interesting for me because I spent 10 years previously in the US after my doing a PhD at the University of Illinois at Urbana-Champaign. And I was working in the field of electronic material science. And we started a first startup company in the US, which was working on the fabrication of high performance concentrated CPV panels. And after spending about 7 years working with a startup, I decided to move back to France for family reasons. And I wanted to continue and start another business in the same field. So initially we developed a dual axis tracker, which was very specific for this high concentration panel, where you need to follow the sun very, very precisely because you're concentrating the light with a magnification factor, which was higher than 1000. So you basically have 1000 sun on each solar cells. And one solution to reduce all the thermal issues was to cut down the size of these solar cells. So traditional CPV module use large cells and to use large heat dissipator to be able to evacuate all this heat. And we use a completely different approach. We're working on micro solar cell, which was only about 600 micron in terms of size. So that solves all the heat dissipation issue. Unfortunately, things don't always goes as well on the market side, and it's been very, very difficult to get this technology to a state where it can be bankable, where it can be financed by bank with non-recourse financing, because you need to have very well-established technologies to be able to do that. And in the meantime, standard PV module price decreased by a factor of 5. So it was extremely difficult to catch up with just the baseline technology, which is amazingly cheap today. You can actually buy a solar panel now for less than 20 cents per watt. I was remembering when I was working back 10 years ago on the Sunshot initiative with the Department of Energy. The goal was to try to reach less than $1 per watt installed PV in order to reach a cost of energy which is lower than 6 cents. And today you have PPAs for large solar plants, which are being negotiated at less than 2.5 cents. So it's by far the cheapest way of producing energy today on the planet if you have good resources. So we've been talking previously about water issues, and I would like to start here with a very dry environment. Here we're in Dubai, close to Dubai, in a mining site where we have about 170 of our 1.5 axis trackers, which are being coupled to a diesel generator and a battery pack. And this is a completely off-site power plant. So it is being used for the large mining equipment that you see here in the back. So this is a good example of a target application that we are focusing on with our 1.5 axis tracker, because we're trying to target initially small scale applications. So this is only a 1 megawatt plant, which is for large cell utility solar plant, a very small installation. So you can switch to the next slide. So Helios Lite is really a small company or startup company, and we're trying to position ourselves as a technical challenger. So we're trying to bring new technologies, new way of doing tracking and fixed structure also. Initially, we'll talk more about this 1.5 axis tracker, which is currently deployed in about 8 countries. And we have about 400 units of these trackers, which are being deployed today. And I will explain a little bit why we call it 1.5 axis tracker. And as a growth relay, today we're focusing most of our development on a new solution for floating PV, which is a fast-growing market. So every time we're trying to develop a new technology, we are really focusing on material usage, and that's where the Helios Lite name comes from. Helios is for the sun, and Lite is for lightweight, because we're trying to cut down every time material usage. Because when you're trying to develop a new product, there's one thing you cannot fight again is material cost. So there's nothing you can do about it. Material cost will evolve, and you can do nothing to control it. So the only thing that you can control is the amount of material that you're using. So our 1.5 axis tracker was really designed to be a lightweight structure and to position ourselves between a single axis tracker, which is today the solution which is used most of the time for very large scale solar farm, because it's more competitive and fixed structure if you have good irradiance to use a single axis tracker. But the energy gain that you get with a single axis tracker is not very high, especially if you do an installation at latitude which is above 30 to 40 degrees, which is the case in France and for most of the US. Then during winter time, at midday with a single axis tracker, the panels are flat, and so you have a dip in the production curves. So it limits the gain that you can get with a single axis tracker to about 20%. On the other side, you have dual axis tracker, but they tend to be very expensive structure, and so you don't see a lot of them, or only for niche application. So we've developed a solution which is in between the two. We use only one actuator to move a structure which has 2 axes of rotation. And the 2 axes are linked together to have a trajectory which is closer to the sun trajectory. So you get the benefit of the high gain, about 90% of the gain of the dual axis tracker, but at a cost which is very close to a single axis tracker. So you can move to the next slide. The next slide, please. Yep. So as you can see here, this is some example of some installation that we've done in the Middle East, mainly close to Dubai, where you can see the curves on the left is the production curve in yellow, which is very square and much flatter than the curve that you can see below for east-west structure, which is trying to increase a little bit the number of hours when you're producing the energy during the day. You can do that with a fixed panel by doing an east-west structure, but it doesn't really flatten much the curves. And when you're connected to industrial site and you're not connected to the grid, it's very important to make this curve as flat as possible, because you're the only energy producer, so you cannot rely on the grid. So it's very, very important to have an energy production curve that matches the load. And so the other very interesting thing about a 1.5 axis tracker compared to a single axis tracker or an east-west structure is you cut down also seasonal variation. So during the winter time, you have the highest gain where you actually need more energy because you have actually less sun. So it's an interesting characteristic which makes this single 1.5 axis tracker very suitable for off-grid or industrial sites. So you can move to the next slide. So initially we focused mainly on system for ground mounted solar installation. And recently we've seen that the floating PV market is really a fast growing market, and we see very interesting opportunity in this market, which is still a fairly new market, so it's still open to innovation. So it's a good fit for a startup company, because when you're trying to bring innovation to a very well established market, it's very difficult to win the price gain, the price war against very large established corporation. So we're currently focusing on this application. So you can move to the next slide. And there's been so far pretty much only one solution which have been deployed in the floating PV, which is basically a fixed solution which rely on plastic floats. So you have a couple variants from several vendors which are currently being sold in this market, but most of the solution look at about the same. They are simple plastic floats which are typically manufactured by injection molding. And these solutions have about 5 years of internal experience now. And there's been recently some very significant damage which have been reported on 2 of the largest plants in Japan, because there was some high wind and the water was a little bit above the maximum limit, and the rope have pulled too strongly on actually the side of plastic floats, which are broken, and almost the entire actually plant has been destroyed, and the panel even caught on fire, because the plastic floats can actually melt under high temperature. It's been pretty much bad publicity for this type of solution, because of course this was on a reservoir which is actually used for drinking water. So you can imagine that's not very good to have something which catch fires. And most of those systems deployed to date are also difficult in terms of maintenance, because you need to walk on narrow lanes of plastic floats in order to be able to replace the panel. So the maintenance costs are quite expensive compared to standard land-based installation. So you can move to the next slide. So with Helios Lite, we're focusing initially on the development of a tracking floating PV solution according to the requirements of EDF, because in France we have a large dams for hydropower, and currently the solution which rely on plastic floats are typically not compatible with this environment, because if you get snow falling on basically the plastic floats and the panel, the entire actually solution sink or often get breakdown. And so we've decided to develop a solution with a tracking system, so you can actually dump the snow as it's falling on the panel. You can dump the snow in the water. And we've recently passed the first winter with this installation. So you can see a recent image of this installation. Here, the panel are in the flat position, and you can see on the left, they can be inclined to about 40 degrees. So at 40 degrees, the snow can actually fall into the lake. And this solution is relying on a structure which is made out of aluminum only. So we have structure which is 100% recyclable, so we use no plastic. So that's a big difference compared to a standard installation. And the structure has been designed to withstand very high wind, because when you have a high wind, you can put the panel in a flat position, and so the wind loads are extremely small compared to a standard installation. So you can move to the next slide. So we've done many prototypes trying to optimize mainly the way we are able to turn the structure. So the structure more or less works like a submarine. So we're injecting air or water inside tube, and they go up and down to the surface. So we don't use any motor. What's very important of maintenance, because we don't want to have electrical or mechanical part that you need actually to fix, because they'll eventually break down. And so we are moving all the control to the shore, and on water we just have basically a conduit to be able to bring compressed air to the different tubes and be able to turn the structure to east or west. So we've done 3 basically design of prototypes, and the last version is the one that you can see on the right, which is currently under test on a high altitude site, which is located in the ski resort of Courchevel at 18-15 meter in height, in altitude. So you can move to the next slide. And as we're talking to a lot of project developers, they've expressed some interest for this tracking system, but they told us, why don't you also not make a fixed structure? Because currently most of the market is in Asia, and this market is interested in fixed structure. And so we've decided to do a simple variant of our tracker system, where instead of having 4 tubes, we only have 2 tubes per structure. It's the same type of structure with a structure which is made out of aluminum. And the big difference compared to plastic floats is that we have the ability to send the raw aluminum coil on site, and then the coil can be turned into tube directly on site. So we can cut down transportation costs, which is a big cost factor for plastic floats. So you can move to the next slide, which summarize some of the difference between existing technology, which are being commercialized by companies like Lite, which is the leader currently. It's a French company, and then Sungrow is now outgrowing Lite in Asia because they are growing very, very fast. And EasyFloat is a Spanish company. And all these solutions rely on plastic floats, which use about 49 tons of plastic per megawatt. So it's a very, very large amount of plastic. And with our solution, we have only a buoyancy airbags, which are inside the aluminum tube, which consume a very, very small amount of plastic because it's a very thin layer. And the rest of the structure is made of aluminum. As you can see, it's very lightweight. We use about 3 to 4 times less material compared to plastic floats. And we can manufacture the tube on site, so we can also save transportation costs. So that's also an interesting factor. In terms of carbon footprint, of course, if you can make aluminum from hydropower, and that's the case with, we've signed a partnership with North Hydro, which is one of the leaders of aluminum product. And they can make low CO2 grade aluminum because they're using mainly hydro to produce the aluminum. Because as you probably know, aluminum requires a lot of energy to be able to convert the bauxite into aluminum. We're also trying to change the way the structure are being installed, because right now the plastic floats take a lot of hand assembly. It's basically they have to be assembled one at a time, one float for one panel. With our structure, we can have actually up to 5 panels on 2 tubes. So it takes a lot less time, man-hours, to be able to build the plant. And we can also benefit from having basically water lanes between the row of floats. So for the maintenance, instead of working on the structure, we can use a platform which looks like a catamaran, which can navigate between the row of floats. So this really facilitates the maintenance operation. And in terms of safety, we've also developed a different way of doing the mooring and anchoring of the system. Instead of attaching the ropes only to the border of an island, we have ropes which are going under all the floats. And so we have a redundant architecture. So even if you have one float which is no longer connected, it doesn't have impact on the other floats. So it's really separate the mechanical to the structure. So that's also interesting in terms of reliability.
To close, Etienne.
Yep. And I think that's actually my last slide. These are 2 pilot projects that we're currently developing in France for about 40 kilowatt project. And we have under negotiation now another pilot project, which is on the reservoir, which is used for agriculture, so for watering. And the next pilot project under development will be in Brazil for a 1 megawatt scale project. Thank you for your attention.